Hello. Today we're going to talk about 11.3, probability of multiple events. So the first thing we need to understand is independent or dependent events. All right, if two events are independent, that means that their outcomes aren't affected by each other. Okay, so for instance, in example 1, rolling a number cube, also known as dice, okay, then spinning a spinner. Okay. Well, whatever I get on the dice doesn't affect the spinner, right? Those are two independent events. Number 2, if you pick a flashcard and then you select another one, well, if I select one, I know I have 30 cards to choose from, but then my next selection will be something out of 29 cards because I have taken one. So since they affect each other, these would be dependent. All right, what about number 3? If we select a coin, okay, at random from our pocket, and then we replace the coin and then select again. Well, then in that case, each pocket, okay, each time we select from our pocket has the same items in it. Okay, so since we replace it, that would be independent. All right, so let's do some probabilities with that. So in this example, we have a picnic. Pause it, read it. All right, if you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and fat-free chips? Okay, well, the probability of getting a diet drink, well, there are 10 diet drinks and 5 regular. So there are 10 out of 15, so 2/3. The probability of getting fat-free chips, well, there are 8 fat-free bags of chips out of 20. So that would be 2 out of 5. So what's the probability of getting both? Well, since they don't affect each other, right? Since they are independent events, okay? Just because I picked a diet drink doesn't mean I'm going to pick a certain kind of chip. So the probability of having both is just 2/3 times 2/5. You just multiply them. If I want both things to happen and they're independent, I multiply. So that probability of that happening is 4 out of 15. Now, the second concept you need to understand is mutually exclusive. Mutually exclusive events means they cannot occur at the same time, meaning there is no overlap. Okay? So this means no overlap. So if you roll a standard number cube or dice, are the events mutually exclusive? So, first one, rolling a 2 and a 3. Well, rolling a 2, there's only one option. Rolling a 3, there's only one option. There's no overlap. So, are they mutually exclusive? Yes, they are. All right, I'm writing this out because I get kids all the time that are like, oh, I put no, but I thought you said the other thing. No. Yes, they are mutually exclusive. All right, the second one, part B, rolling an even number. So my options are 2, 4, 6. Getting a multiple of 3 is either a 3 or a 6. Well, we do have an overlap, so no, they're not mutually exclusive. All right, part C, rolling an even number. My options are 2, 4, 6. Prime numbers. That would be 2, 3, and 5. There is an overlap with the 2, so no, they are not mutually exclusive. Part D, rolling an even number and rolling a number less than 2? Well, the only thing less than 2 is 1. No overlap. So, yes, they are mutually exclusive. Okay. All right, we talked about the probability of and situation, so let's talk about an or situation. The probability of A or B means I don't care if one happened and the other one didn't. Okay? Probability of A and B means I want the overlap. Right? Remember we did that with inequalities. And is the overlap, or is everything. So I want the probability of A and the probability of B. But remember, like a Venn diagram, we have that extra overlap. So we have to subtract the overlap, which is the and situation, because and is the overlap. Okay, so and is the overlap, where or is everything. All right. So let's do number 6. So a student can take one foreign language each term. Gives us a probability of Spanish, probability of French. What is the probability chosen at random is taking Spanish or French? So Spanish or French. So probability of Spanish plus probability of French minus the probability of both. So probability of Spanish is 0.37. Probability of French is 0.15. And the probability of both, well, there is no overlap, right? They can only take one foreign language at a time, so that probability is 0. So then our answer is 0.52, or 52%. Okay. Problem 7. All right, so 9% take Chinese. What's the probability that they take Spanish, French, or Chinese? So we already know the one for Spanish and French. We just need to tackle on Chinese. So Spanish or French or Chinese. What's nice is, again, one foreign language at a time, so there's no overlap. So we literally just add them all up. So probability of Spanish plus the probability of French plus the probability of Chinese. 09. And so that is 0.61, or 61%. Okay, so let's do some more practice problems. So you can either use the formula or you can just count it up and do it that way, but I like to show you where the formula comes from, because sometimes you do a problem and it's maybe not as easy to see it. Maybe you have to use the formula. Okay, so I'm going to use the formula for these. So probability of choosing a square or yellow. So that's the probability of a square. This is or. So square plus the probability of yellow minus the probability of both. Well, there are 3 squares out of, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Plus the probability of yellow minus the overlap. There are no yellow squares. So our answer is just 4 out of 9. All right, the next problem. All right, choosing round or green. So probability of round is 5 out of 9, plus the probability of green is 3 out of 9, minus the overlap. We get 6 out of 9, or 2/3. Okay. So again, you could have just counted all the green or round things. Okay. And part C, we have square or red. We have 3 squares and 3 reds and only 1 red square. So we get 5 out of 9. And the last one, green, 3 out of 9, square, 3 out of 9, overlap, 1 out of 9. So we get 5 out of 9 again. All right, if you have any questions about this, you know where to find me.